Here is question from JEST 2016 from Electrostatics. In this question it is given that a point charge Q of mass m is released from rest at a distance d from an infinite grounded conducting plane. Ignore gravity. How long it will take for the charge to hit the plane? Four options are given here. Now we have to solve this question. So let's solve the question. Solution. So it is given in our question that there is a plane. There is a conducting plane. This is our conducting plane. That is our conducting plane. And a charged particle is falling down. So this is our initial situation or initial position of our charged particle. This charge is equal to plus q, and it is situated or located at a height x from the conductor. Now this metallic conductor or conducting plane will act as a mirror of this charge. If it acts as a mirror of this charge, then there will be a negative, same and opposite negative charge q will appear here at the same distance. Now the magnitude of this distance is equal to d here, and let this is the origin of our coordinate system, and this distance is indicated x distance. Now from Newton's law of motion we know F means force equal to mass time acceleration ma, which is equal to m into d2x with respect to dt square. Now but electrostatic force of attraction between these two charges will be equal to -1 divided by 4 pi epsilon naught, and because this distance is plus d and this distance is minus d, so that total distance will become, in aggregate this total distance will become 2d. So our force will be 1 divided by 4 pi epsilon naught q into minus q divided by 2d square. So magnitude of this force will become -1 divided by 4 pi epsilon naught q square divided by 4d square. Let this force, now this acceleration, therefore we can write d2x with respect to dt square is equal to minus a divided by x square, where a is equal to q square divided by 16 pi m epsilon naught. From this equation we can write as the d2x with respect to dt square can written in the form of dv with respect to dt is equal to minus a divided by x square. Again we can write this term as v into dv with respect to dt is equal to minus a divided by x square into dx with respect to dt. Therefore half into d dt of v square will become d dt of a divided by x. So if we integrate this equation, we'll get, after integrating we'll get v square is equal to 2a multiplied by 1 divided by x, v square divided by 2 will be a divided by x plus c. But now we have to apply the initial conditions. For initial conditions, the boundary condition is given as when x equal to d, means distance is d, then motion is just start, then its velocity will be 0. When x equal to d, v equal to 0. Therefore if we substitute the value of x and v here, then we'll get 0 square divided by 2 will be equal to a divided by d plus c. Therefore we can get the value of c as c will be equal to minus a divided by d. So from this equation, if you substitute the value of constant, then we'll get v square divided by 2 will be equal to b square divided by 2 will be equal to a divided by d minus now our equation a divided by x minus a divided by d. Now we can take this a as common. If we take the a common, then our term will become a into 1 divided by x minus 1 divided by d. Now we can cross multiply this. If we cross multiply this, then this term will be equal to b square into 2a into 1 divided by x minus 1 divided by d. So from this equation we can write b will be equal to under root 2a into under root 1 divided by x minus 1 divided by d. Now as v is nothing but rate of change of velocity, therefore we can write this v term as dx with respect to dt, but the motion is in negative direction, therefore we can write minus dx with respect to dt is equal to root 2a under root 1 divided by x minus 1 divided by d. So if we cross multiply this, or we can again write dx with respect to dt minus dx with respect to dt will be equal to under root 2a under root xd into d minus x. So if we cross multiply this term, then we'll get xd divided by d minus x under root into dx will be equal to minus root 2a into dt. Now we have to integrate this term. Now after integrating, if we integrate this equation, then we'll get integration of this equation will become from limit 0 d to 0, because motion starts from a distance d, and when it reaches to the conducting plane or ground, then its distance will become 0, and time starts from 0 and it ends at time t. Now we have to substitute some quantities, so let or putting x equal to d sin square theta. If we take x equal to d sin square theta, therefore we can write dx will be equal to 2d sin theta cos theta d theta. Now if we substitute these quantities, then we'll get the integral will become integration from pi by 2 to 0 of d sin square theta into d divided by d cos square theta into 2d sin theta cos theta d theta. This term will be equal to under root 2a multiplied by t. Now after proper substitution, we'll get the value of minus root 2a into t will be equal to integration from the limit minus pi by 2 to 0 root d into sin theta divided by cos theta into 2d sin theta cos theta d theta. So this term will become 2d to the power 3 divided by 2 integration from pi by 2 to 0 of sin square theta d theta. Therefore our integral will become minus root 2a into t will become 2 d to the power 3 divided by 2 integration from pi by 2 to 0 1 minus cos 2 theta divided by 2 d theta. This term will become d to the power 3 by 2 into integration of d theta is equal to theta and integration of sin cos 2 theta equal to sin 2 theta divided by 2. With it limits pi by 2 to 0. So if we put this limit, then we'll get minus root a into t will become minus d to the power 3 divided by 2 into pi divided by 2. Therefore we can write this expression as minus root 2a into t will become equal to minus d to the power 3 by 2 into pi by 2. So from this expression or equation we can write, if we put the value or substitute the value of a from our equation, because at the beginning we took the value a equal to q square divided by 16 pi m epsilon naught. Now we have to put or substitute the value of a, then our value will become minus root 2 into a. Now the value of a is equal to q square divided by 16 pi m epsilon naught, and it is again multiplied by t equal to minus d to the power 3 by 2 into pi by 2. Therefore this negative and negative sign will cancel each other. So if this term cancel each other, then our value of t or time will becomes d to the power 3 by 2 multiplied into pi by 2 multiplied by under root 8 pi m epsilon naught divided by q square. So which is equal to under root 2 pi cube epsilon naught m d cube divided by q. So therefore the value or required time to hit the ground of this charge will be equal to t. Therefore t will be equal to under root 2 pi cube epsilon naught m d cube divided by q. Hence in our question four options are given, and among these four options and divided by q, root will be here, and this q term is independent of the square root. So from our given conditions or question, we are seeing that our answer is 2 pi cube epsilon naught m d cube divided by q. Therefore we can write option A is correct.